Hello, this is section 5.3. In your textbook, this would be on page 297. So we've been working on factoring and trying to find solutions for polynomials. And so far, we've been able to manage doing the factoring using a GCF and things like that. And most of our answers or solutions have been coming out to be nice real numbers. And then we made our sketches from there. Today, we're going to look at a special factoring situation. It is called the sum and difference of cubes, okay? And again, this pattern, it's a pattern. I have it written down here on my paper. It is also, again, in your textbook on page 297. It looks a little longer than some of the things that we're used to working with. So when I'm doing this, sometimes I just always look at the pattern to make sure I have all of these signs, especially in the right spot. All right, now it's called sum and difference of cubes, which means we're looking for perfect cubes. Now, perfect cubes are probably things you don't recognize real easily. Perfect squares we're a lot more familiar with, things like 25 is 5 times 5, 36 is 6 times 6. So I have a list of perfect cubes up to from 1 through 10. So you may want to pause this and jot these down so that when you're looking at your problems, you recognize your perfect cubes, okay? And you will notice that when you cube a number, they get very large very fast, which is why most of us don't have all these memorized, all right? But, again, so for example, 1 to the third. 1 to the third is still just 1. 2 to the third would give me 8. 3 to the third, 27, and so on. Okay, so when you're looking to factor a problem and you notice you have an exponent of 3, okay, and if you see any of these numbers, and again, it's going to be just a binomial with a plus or minus in it, okay? So I'll show you what they look like and how you can recognize them, and then I'm going to talk you through the pattern, okay? Again, the pattern, like I said, is in your textbook. So again, you might want to copy that down or just look at your textbook when you are working through your problems. All right, so when you look at your problem, like I said, it will look like something like one of these two. You'll notice that you'll have to have a perfect square in both the front and the back. Okay, and again, it might be a plus or a minus sign. Okay, so when you originally look at your problem, it will look like that. Again, similar to what we talked about before, you want to make sure your problem is equal to 0. So again, if you look down here, you can see it's equal to 0. If it wasn't equal to 0, you might have to, move everything over to get it that 0 on the one side. All right. And again, if you look at the pattern, you'll notice that you're going to, when you factor it, you'll end up with a binomial with a plus or a minus sign, again, depending upon what you started with in the beginning. And then you'll notice the other part, or the other factors, what we would call this, will be a trinomial, okay? So eventually, probably next class, we will do some more factoring with the trinomial once we get this factored for the first time, okay? But today, we're just gonna practice kind of using the formula. How do you factor these sum or difference of cubes? All right? Okay, so let's just kind of get to it here. And I'll show you how the pattern works. All right. So the first thing, like I said, we want to take a look and make sure it equals 0. So here I have my polynomial. We have x to the third minus 216 equals 0. All right. So clearly I can see that x to the third is a cube. Okay. So is this 216 a perfect cube? All right. So if we look on our list, let me go back here. You'll see that 216 is 6 to the third. All right. So when I'm usually doing this, what I like to think about, or what I like to write is, okay, x to the third would be a perfect cube of x. X times x times x. 216 is a perfect cube of 6. So 6 times 6 times 6. All right. So that's what you need to figure out. Once you have that, it's just going to be looking at the pattern and kind of putting these numbers into the pattern. All right, so since this is a subtraction sign, we have a subtraction of my cubes. So again, here's my pattern that I'm going to take a look at. All right, so I'm going to go ahead and draw a little parenthesis here. Inside my first parenthesis, okay, they use the variables a and b. Okay, the a and b are going to be these numbers right here that I figured out. Okay, so that means I'm going to have an x and I'm going to have minus a 6. Okay, then I need to get this whole part of my factors here. So again, I'm going to draw the parentheses. I need 3 things inside here. All right, and if you look at the signs, there's a plus and a plus. So I kind of always just like to put the little plus signs in there, and then I'm going to follow the pattern and fill in these 3 little terms that go here. All right, so this is how I do it. This says a squared in the front. Okay, so again, this right here is representing our a, so I'm going to square it. So in the front, I write x squared. Okay, I always like to do the last one as well because I think it's easier. So at the end, it says b squared. So again, the b is representing what we have here is our 6. So 6 squared, okay, would go here. That's going to be 36. Okay. Now to find the middle, if you look in the formula, you see it says AB. That means I'm going to multiply the A times the B. Okay, so again, going back, these are my A and B values according to our problem. So I'm going to take 6 times x, x times 6, doesn't matter which way you go. Okay, and that goes in the middle. And we have now factored. Okay, so that's it. All right, if you kind of just take a look at what we have, and again, we could check our answer by multiplying this all out, kind of using a big distributive property, but you'd see our x times x squared, you know, that's how we're going to get that x to the 3rd. All right, and again, you can keep on going. You'd have to distribute this all and combine your like terms, but when I multiply these 2 factors together, that would give me my, what we started with, x to the 3rd minus 216. Okay. All right, let's try another one. Number 2. All right, so again, we see that our polynomial is equal to 0, which is good. Okay, we see 2 terms here. We see a plus in the middle. Okay, so this one has a plus. So again, I'm going to be looking at this formula, which is pretty much the same. The only difference in the formula you notice is the signs. All right, so you have to ask yourself, is 8 a perfect cube? And is 1 a perfect cube? That's what you need to be looking for. All right, so again, if I look on my list that I have above here, we can see that 8 is a perfect cube. That would come from 2 times 2 times 2. All right, and since there's a x to the 3rd, okay, I want to think of this as 2x. 2x times 2x times 2x would equal 8x to the 3rd. All right, 1 is also a perfect cube. Probably the easiest one. That is just 1 times 1 times 1. All right, so you want to find those perfect cubes, and I just kind of write them right underneath my problem. So again, this, if you look at your formula, this first little part here in the formula would represent whatever they say A. The second part here, when you look at the formula, that's going to be B. Okay, so again, just like the first one, I'm going to do that first little parentheses here. Inside here, we're going to have a binomial. So if I look at my formula, this one has a plus sign. So if you look in that first binomial, you'll notice there needs to be a plus sign in there as well. So we take our 2x plus 1. So that's my first factor. All right. Then my second factor, I go ahead and make a little bigger room for my parentheses here. And if you look at the signs, kind of follow the pattern, this time we have a subtraction sign and then a plus sign. So I'm going to put my little subtraction sign, I'm going to put my little addition sign, and then again, I need to fill in these 3 terms. All right, so again, looking at the formula, it says a squared. Okay, again, this one represents my a. I need to square this. So 2x times 2x would be 4x squared. Okay, at the end of the pattern, it says b squared. So again, this one represents my b. So when I square 1, that is still 1. So I put that in that last spot. And then in the middle term, it says a times b. So I'm going to multiply my a times the b. So a 2x times a 1 would be a 2x. Okay, and we have now factored it using our sum of perfect cubes. All right. Next time, our very last lesson, we're going to continue on and factor this part here. But for tonight's work, again, all you're going to do is practice following the pattern and doing that first step of factoring. All right. I'll do one more here, see if you can kind of remember what's going on. All right, so example number 3, we have x to the 3rd minus 125. So the first thing I notice here is that it doesn't equal 0. So I am going to go ahead and move the 125 over to the other side. So we have x to the third minus 125 equals 0. All right. We have our two terms. We have subtraction. So again, we'll be using our formula or pattern here with the subtraction. X to the third is obviously a perfect cube of x. So x times x times x. 125, if you might not recognize that, but if you look on my little list, 125 is a perfect cube of 5. So 5 times 5 times 5 gives you 125. All right, so that means my 125, I'm going to put a 5 here. All right, let me slide down so you can see my formula. All right, so here's my pattern. Okay, so again, we had the difference of cubes. Okay, so this is my pattern. This is what my answer is going to look like. So again, follow through the pattern and let's fill them in. All right, so since this is subtraction, again, if you look at the pattern, you notice there'll be a subtraction in the binomial. Okay, again, this first part here represents our A and this is our B. So we have x minus 5. All right, if we look at the pattern again inside the trinomial, you'll notice these are both, again, addition signs. So again, I like to kind of put my little addition signs in there. And now again, follow the pattern. What are the 3 terms that go inside? All right, so in the front, it says a squared. This is representing my A, so we write x squared. At the end, it says b squared. That means I'm going to take my 5 and I'm going to square my 5. 5 times 5 is 25. My middle term, it says a times b. So we take our x times the 5. In the middle, we have 5x. All right, and we have now factored that. All right, so that is what you're going to be doing on your homework tonight. So practice with the pattern. Keep on looking at it until maybe you'll memorize it pretty quickly. Maybe you look at the pattern every time, as long as you know how to get it factored. All right, have any questions, let me know. Good luck.